Section 5-6, graphing inequalities with two variables. Alright, so we're going to graph 2x plus 3y is greater than or equal to negative 6. Now in order to graph this, we need it to be in slope-intercept form. Right now it's in standard form, and we don't want to graph it in standard form. We want to graph it in slope-intercept form. So that means we need to get y all by itself. So we're going to get rid of the 2x by subtracting 2x on both sides. Now remember to keep the negative 2x and the negative 6 separate because they are not like terms. Then to get y alone, we need to divide all three numbers by this 3. So we have y is greater than or equal to negative 2/3 x minus 2. All right, so let's graph this. So our y-intercept is negative 2, so I'll put that dot on the y-axis. Then rise negative 2, run 3, rise negative 2, run 3, rise negative 2, run 3. Now since it's greater than or equal to needs a solid line, because greater than or equal to and less than or equal to have a solid line. And then for the shading, I'm going to put my pencil on my y-intercept. The inequality is greater than or equal to, so numbers that are getting bigger are above my line. So if you think of a number line, numbers get bigger as they go up, smaller as they go down. So I'm going to shade everything above my line. And then I need to name two solutions. So solutions are any ordered pairs that fall in the shaded area, because every single ordered pair that is in the shaded region is considered a solution. So for example, 3, 2, right here, that would be one solution. Another solution could be negative 1, 1. Really, you could list tons and tons and tons of different ordered pairs that would all be solutions. I just picked 2 that fall in my green shaded area. All right, so now we're going to graph x plus 5y is less than or equal to 10. So let's subtract x on both sides. And then we have negative x plus 10 on the right-hand side. Divide every number by 5. And we have y is less than or equal to negative x over 5 is the same as negative 1/5 x. So I'm going to write it like that instead. But you could leave it as negative x over 5 as well. Same thing. All right, my y-intercept is 2, so I'll put my first dot on 2. Rise negative 1, run 5. Rise negative 1, run 5. And we'll do one backwards. 1, 2, 3, 4, 5. All right. So we have less than or equal to, so once again we need a solid line. And then my inequality symbol this time is less than. So if I put my pencil on my y-intercept at 2, less than means shade down. So every single ordered pair shaded in red, in that red region, is a solution. So let's name a couple. How about 3, negative 3 right there? Yep, that falls in the shaded area. So 3, negative 3 would be a solution. Another one, if I do negative 4, 0. Yes, that's in the shaded area. So negative 4, 0 is a solution. All right, and negative 3x plus 5y is less than 10. slope-intercept form, add 3x to both sides. So 5y is less than 3x plus 10. And divide every number by 5. So we have y is less than 3/5 x plus 2. So if I graph this, put my first dot on 2, rise 3, run 5. All right, and this one is less than, so that means I need a dashed line. Oops, something went wrong here. Oh, this dot is in the wrong spot, so let's try that again. So rise 3, 1, 2, 3, 4, 5. There we go. So a dashed line. If I put my pencil on my y-intercept, it's less than this time, so less than means I'm shading down. And then name two solutions. How about 4, 1? And we'll say 5, -3. Those would both fall in our shaded area.
Could a custodian please call extension 6801, a custodian 6801?